Welcome to the DIY Honda Garage channel. The DTC P2182 refers to an issue detected in the Engine Coolant Temperature (ECT) Sensor 2 of a Honda Accord 2023 or newer model. This diagnostic trouble code indicates that the output voltage from the ECT Sensor 2 is outside the specified range recognized by the Powertrain Control Module, PCM. The ECT Sensor 2 plays a crucial role in monitoring the temperature of the engine coolant. This temperature data is essential for optimizing engine performance, improving fuel efficiency, and regulating emissions. The sensor is located within the engine bay, typically near the engine block or cylinder head. If it malfunctions, the PCM will store this error code, indicating an abnormal condition that requires further investigation. Understanding this problem is critical not only for diagnosing malfunctions, but also for preventing potential engine damage due to improper temperature readings. The primary component affected in DTC P2182 is the Engine Coolant Temperature (ECT) Sensor 2. This sensor is designed to measure the coolant's temperature, which directly affects engine performance. The ECT sensor's location is generally near the engine cylinder head, ensuring it accurately reflects the coolant temperature circulating through the engine. Its output is transmitted to the Powertrain Control Module, PCM, which uses this data to manage engine functions such as fuel injection and ignition timing. If the voltage from the sensor falls below 0.16 volts or exceeds 4.92 volts, the PCM recognizes an out-of-range condition, leading to the logging of DTC P2182. Therefore, the health of the ECT sensor is paramount, as it provides vital data for the correct operation of the engine system, affecting efficiency and emissions. There are several possible causes for the activation of DTC P2182. First, the most common cause is a faulty Engine Coolant Temperature (ECT) Sensor 2. Over time, this sensor can fail due to electrical issues or internal damage, leading to inaccurate readings. Second, there may be problems in the external circuit, including wiring or connector issues associated with the ECT sensor. These could manifest as open circuits or shorted connections that disrupt the sensor's ability to transmit accurate voltage readings to the PCM. Lastly, if the previously mentioned components check out, the concern might be with the Powertrain Control Module itself. Although PCM failure is less common, it can lead to misreadings and malfunction of system diagnostics, affecting overall vehicle performance. When DTC P2182 is triggered, several symptoms may be observed in the vehicle. The first sign is often an engine overheating condition, as the PCM may inadvertently receive incorrect temperature readings, leading to faulty cooling system adjustments. This overheating can further stress other engine components, potentially leading to costly repairs if not addressed promptly. Another common symptom includes poor fuel economy, as the engine may operate inefficiently due to improper temperature regulation. Drivers might also notice that the check engine light is illuminated, providing a direct alert that there is an issue with the ECT Sensor 2. These symptoms highlight the importance of timely diagnosis and repair to maintain optimal vehicle health. In the first troubleshooting step for DTC P2182, begin by turning the vehicle into the on mode without starting the engine. This action activates the vehicle's electrical systems, allowing for diagnostics through the Honda Diagnostic System, HDS. Once in this mode, verify the voltage output of the ECT Sensor 2 using the HDS diagnostic tool. A normal range for the ECT sensor's voltage should be between the specified limits. Any reading below 0.16 volts or above 4.92 volts indicates an immediate fault condition. If the output voltage fails to meet this criterion, the next steps will involve inspecting the sensor itself and its connections to determine why the PCM perceives it as malfunctioning. This initial verification is crucial to isolate where the problem may arise from. The second step in troubleshooting DTC P2182 requires you to first disconnect the ECT Sensor 2 connector, which consists of two terminals. This disconnection is essential as it allows for a controlled inspection of the sensor's voltage output. After disconnecting the sensor, utilize a jumper wire to bridge terminals number 1 and number 2 of the ECT sensor connector. Following this, turn the vehicle back to the on mode while monitoring the ECT Sensor 2 voltage through the HDS. A reading that is less than 4.92 volts during this test indicates that the ECT sensor itself is at fault. Conversely, if the voltage is still abnormal, it points to potential issues in other related circuits or components, thus guiding the technician toward further diagnosing the root cause. In troubleshooting Step 3 for DTC P2182, disconnect both the ECT Sensor 2 connector and the PCM connector. This approach allows for a thorough inspection of the circuit integrity between the sensor and the PCM. Assess the TW2 sensor signal line and the SG6 ground line for any obvious signs of damage, such as cuts or frays, which could interfere with electrical signals. Check the resistance levels. Normal conditions dictate that the resistance should be less than 1 ohm, indicating a healthy circuit without any interruptions. If the resistance reading exceeds this value, or if the circuit exhibits open wiring, this suggests a fault in the wiring that needs to be resolved. If the circuits are intact, but the sensor readings remain abnormal, focusing on the sensor itself or the PCM should be prioritized next. The fourth and final troubleshooting step in diagnosing DTC P2182 involves conducting a thorough inspection of the powertrain control module, PCM. By examining the PCM closely, technicians can assess its overall functionality and operational integrity. If earlier inspection items have indicated normal conditions and no issues were detected with the ECT sensor or its circuits, then the likelihood of the PCM being the cause increases. It's essential at this step to ensure that all other connected components are functioning correctly. Anomalies in the PCM operations could lead to miscommunication with other system components, causing engine performance issues. If, upon inspection, it is confirmed that the PCM is indeed malfunctioning, replacement or reprogramming may be necessary to restore proper vehicle operations. Once all troubleshooting steps have been completed and repairs made, it is imperative to perform a final verification of the repairs to ensure that DTC P2182 is fully resolved. Begin by using the diagnostic tool to clear any stored DTCs from the PCM. After clearing the codes, take the vehicle for a test drive to replicate typical driving conditions. After the drive, perform a scan again to check for any persistent diagnostic trouble codes. If DTC P2182 reappears, further investigation may be necessary to identify any lingering issues. Lastly, confirm the engine runs smoothly without any unusual symptoms related to cooling or power, assuring that the repair has been effective and that the vehicle is back to optimal performance. Preventive maintenance plays an essential role in avoiding future occurrences of DTC P2182. Begin with regular inspections of the ECT sensor wiring to identify any signs of wear, damage, or corrosion that could affect performance. Maintaining the quality of engine coolant is equally important. as contaminated or old coolant can lead to inaccurate temperature readings and potential sensor failure. Ensuring that sensor connections are secure and free from contaminants can prevent connection-related issues before they arise. Incorporating these routine checks into standard maintenance can significantly extend the lifespan of the ECT sensor and ensure the cooling system operates effectively, reducing the likelihood of overheating and costly repairs. In conclusion, DTC P2182 highlights a critical issue regarding the Engine Coolant Temperature Sensor 2 in the Honda Accord 2023 and newer models. A thorough and systematic troubleshooting approach is essential to identify the root cause of the error code, whether it lies within the sensor, the circuit, or the PCM. Promptly addressing any findings can prevent significant performance issues, such as engine overheating or decreased fuel efficiency. Furthermore, instituting regular preventive maintenance measures can help safeguard against the future occurrence of DTC P2182. Ultimately, understanding the vehicle's cooling system and working diligently to maintain it will ensure the engine operates at peak performance. Please like and subscribe to the channel. See you next time.